Hello and welcome to our presentation slides of KNR3193 microprocessor. We are from group 15 and our group name is Ryzen9 3950X. My group members are Pilemon, Vinci and Andrew Shampurai. The title for our presentation is Ryzen 3950X. First of all, what is Ryzen 3950X? Ryzen 3950X is a family of high-performance 64-bit hexadecimal core x86 that is designed by AMD and manufactured by TSMC. Hexadecacore is actually referred to 16 cores on a single die, and x86 is an instruction set architecture. This type of Ryzen is designed for socket AM4 platform. AM4 platform is an AM4 microprocessor socket for AMD's CPU built on Zen, such as Zen Plus and Zen 2. This Ryzen 9 3950X is built with Zen 2 microarchitecture, which is improved architecture designed from Zen Plus, and it is a 7nm processor that has high performance using 3800 million transistors. There is actually a lot of improvement from Zen Plus to Zen 2 microarchitecture, such as improved micro-op cache tag, increase in dispatch bandwidth to improve the instruction stream, improve micro-op to 4096 entries, 2 times wider data path, and additional address generation unit AGU. Now we will be talking about the specs on Ryzen 9 3950X. Ryzen 9 3950X has 16 cores and 32 threads, which is highly suitable for gaming, multitasking, productivity, that is for content creators. It also runs at base clock speed at 3.5 GHz and maximum boost clock up to 4.7 GHz. Maximum boost clock for AMD processor is the maximum frequency achievable by a single core on the processor running a single-threaded workload. Next, the thermal design power TDP rating is 105 watts, means that the power is running at 105 watts. And the memory cache for L1, L2, L3 is 1 MB, 8 MB, and 72 MB. Next, I will be explaining about the Ryzen 9 3950X architecture, which is the Zen 2 microarchitecture. Zen 2 is a front end that consists of prediction unit, micro-op queue, op cache, decode, and 64K cache 4-way for the instruction fetch and decode. It also has an integer execution unit, floating point, and load store unit. For the instruction fetch and decode, the instruction fetch unit reads 32 bytes per cycle from a 32 kilobytes 8-way associative LI from the LI instruction cache, and the cache line size is 64 bytes. Cache line are fetched from L2 cache, which has a bandwidth of 32 bytes per cycle. 20 entry instruction bytes queue decouples the fetch and decodes the unit. Each entry holds 16 instruction bytes, and then the 4-way decoder sends 4 instructions per cycle to op cache and micro op queue. Then it will go through the stack engine main file, microops, sequencer microcode ROM, and the dispatch unit distribute microops to the integer and floating point execution unit, where it can dispatch up to 6 microops per cycle to the execution unit and 4 microops per cycle to the floating point unit. Next, I will explain briefly about L1 perceptron. That is the simplest form of machine learning algorithm inside the front-end unit of Ryzen9 3950X. The method is accurate, but the implementation is complex, which means the method of deciding which branch is taken is accurate. So, when the processor encounters a conditional branch, its address is used to fetch a perceptron from a table of perceptron. The inputs is the individual bits and the output is the computed dot product of the weights and history of prior branches. Now, if there is a negative output, the branch will not be taken. Next, L2 tag is the second layer of predictor inside the front-end unit. The concept is that different branches in the program require different history lengths. The function is to figure out which amount of branch history is the best to be taken out, where the priority is the longest history length. The integer execution unit consists of a rename unit, 5 schedulers, 180 entry physical register file, 4 LRU, and 3 AGU pipelines. There is also a 2 to 4 entries in the entire queue shared with the floating point unit. The floating point consists of a rename unit, non-scheduling queue, and LDCVT, which is to convert data to the internal register file format. And there is also a 160 entry physical register file and a 4 execution pipelines. The function of FP is to load and store co-op the execution unit for address calculation and the LS unit for memory accesses. Now, the function of load store LS unit is to handle memory reads and writes. The load store unit has 44 entries of load queue that receive load operation from the AGU in the execution unit, and the LS unit depends on a 32 kilobyte 8-way associative and 64 cache line size.
Hi, my name is Andrew Shampurai Anak Jampi, and for my part, I would like to talk about the Ryzen 9 3950X regarding its base system. In Ryzen 9 3950X base system, it has Zen 2 as the microarchitecture. So in Zen 2, it has CCX, known as core complex. As we can see in the figure shown, there are four of the CCX. This CCX also known as the associated core structures. For the single core complex was 60 square millimeters, and each core can access each cache slice of L3 with same average latency. It is crucial to note that the L3 in Zen 2 is not a true last level cache, as the 16 MIB L3 will consist of two separate 8 MIB and not one unified L3. By using the Infinity Fabric, the separate CPU complexes can interact with each other, which connects the CCX along with the memory controller and input-output. This design choice allows for the scaling up to a large multi-core high-performance system, such as high high scalability, particularly in the server segment, through high core count and large bandwidth.
Then two processors have to treat every CPU complex as a processor of its own, such as schedule tasks using cache-coherent non-uniform memory access scheduling. This is crucial so that to prevent unnecessary performance penalties and also to ensure that threads are not moved from one CCX to the others. Cache data also would need to be communicated over via the fabric from one CCX to the next, which has additional overhead latency and lower bandwidth. So even though L3 reside on the same die, CCX are not directly related, so the CCX must pass through the scalable data fabric on the input-output die for the request leaving.
So next, I would like to talk about the memory subsystem. The memory subsystem has been enhanced on Zen 2. The L2 data TLB is now 512 entries bigger, and for the load loops may be executed on AGU0 and AGU1, while stores can be sent to any of the three units. The memory bandwidth for the data cache has also doubled by accommod- accommodating the widening of the FPU units. Zen 2 is now capable of performing full 256-bit stores and loads. Doubling the bandwidth to 64 bytes will have a positive impact on a class of workloads that relies heavily on copy or stream tasks.
Hello everybody, for my part, I will talk about a comparison between our selected processor and the 8086 microprocessor. Before we get started, I will show you guys the background of the 8086 microprocessor. The 8086 microprocessor is the enhanced version of the 8085 microprocessor. It is an integrated circuit with all the functions of a CPU, however, it cannot be used standalone since, unlike a microcontroller, it has no memory or peripherals. The microprocessor does not have RAM or ROM inside it. However, it has internal register for storing intermediate and final result, and interface with memory located outside it through the system bus. It is also the first 16-bit microprocessor which were designed by Intel and the first member of the x86 family processor. Intel designed this microprocessor between 1976 and 8 June 1978 and released it on the 1st of July 1979. The microprocessor was built in 40-pin dual inline package IC and manufactured using the high performance metal oxide semiconductor technology, and it has transistor count approximately about 29,000 transistors. So let us compare these two. First of all, as you can clearly see, the difference is their physical form. Obviously, you can see that the Ryzen 9 3950X has better designs and look more modern than 8086 microprocessor, since it is newer and latest. Next, the architecture used for the 8086 microprocessor is x86-16 manufactured by Intel. Meanwhile, Ryzen 9 3950X, which were manufactured by AMD, uses the Zen 2 microarchitecture as their instruction sets. The data width for 8086 is 16-bit with the clock speed from 5 to 10 MHz, while the Ryzen 9 is 64-bit with the clock speed of 3.5 to 4.7 GHz. The 8086 doesn't have any RAM or ROM, while Ryzen 9 can support memory up to 128 GB with the speed of 3200 MHz. To power an 8086 microprocessor, it only needs a single 5V from a power supply, while Ryzen 9 3950X has the maximum power consumption of 137 W. The differences between both of these microprocessors also can be seen by their transistor count. The 8086 microprocessor has 29,000 transistors, while our selected microprocessor has around 2,800 million transistors. For their prices, the most expensive we can get for 8086 microprocessor during its era was about $200, while Ryzen 9 3950X costs about $700. To conclude our presentation, our selected microprocessor is a high-performing 64-bit hexadecimal core x86 with 16 core and 32 threads. Its memory can support up to 128 GB DDR4 at its max, with clock speed of 3200 MHz. The max power consumption of this microprocessor is up to 137 W. The architecture of this microprocessor is Zen 2 microarchitecture of 7nm processor, where it can performing full 256-bit stores and load. We can see a big difference where it was compared to Intel 8086 microprocessor, since our selected microprocessor has features which are more newer and more high performing. That's it from us today. Thank you for listening and have a nice day.